Okay, now we're going to talk about the topology optimization further on. Now I'm going to show you one possible method if you want to have an optimization of one part of the structure, but still maybe another part of the structure should be untouched. It can be like two different materials that you want to say, okay, this material should not be optimized. It can be kind of a constraint that the designer tells us like, okay, this part is necessary in order to join or attach two different parts together. So structure, maybe some part of it is a constraint, do not touch, do not change kind of constraint. So what we can do is in this Beso optimization algorithm that we can generate different domains or different materials, so to speak, and then say, okay, this material needs to be optimized, but this material will be left untouched. In order to do so, we have to have two different materials. So in other way to say, we have to have two different bodies. So now this is why I'm going to create one body and another body, and I'm gonna use them, both of them together. So let me create a body which is, let's make it really simple. So just gonna make it a cube here. On the fly, I'm doing now three-dimensional in the part. Of course, you can do it in part design with a sketch of more complicated geometries as well. But in order to give the idea what we're gonna do, this is actually already good enough. So I'm gonna make it maybe a little bit longer, but that's just, I have something in mind, so this is why I'm making it a bit longer. So maybe this is better. So roughly speaking, this is 30 millimeter long, and then maybe make it a bit less wide, a bit more wide, so 30 to 70, and then I'm going to make a hole in it. So let me make a hole here. This cylinder goes a bit more into the inside. Let me put it, for example, here. Okay, so I have something like one cylinder which is going to be used in order to attach something. So that means this cylinder will be cut, and then I need to have another cylinder as well in order to cut from this cylinder, which is like this tube. So I want to have a tube which is maybe that one is fine. I'm just gonna say okay, and this tube needs to go to the position, to the same position as the other one. I guess it is here. Okay, so I can have like 1 millimeter more. I'm gonna be ready at the same position. So this is the tube that I have. So I can have the outer radius a little bit less. Why not? And what I have in mind is this tube will be left untouched. So I don't want to have a topology optimization there. So first of all, I want to get rid of from the cube. I want to subtract the cylinder and subtract the tube as well. In order to do so, I'm going to use this Boolean operation. So I can choose here from the list Boolean operation, and then say what I want to have is from this cube. I want to subtract or take it out the tube and the cylinder itself. So then if I say close, then I have here a cut. So let me show you which one is which one. I'm using now the space. If I select it and use space, then it will be, it will be invisible. I will just take it out from the screen by using the space, or here from the cut, I can use space and take it out. So there's a cut here, which is okay. So, and there's also this tube. That's this tube. This is also okay, but what I want to have is from this cut, I want to cut the tube as well. So here I'm cutting the tube from this part. Again, Boolean, I can choose and say from this cut, this is the new part, I want to take the difference or subtract this tube, which is a compound. So you see here there are solids, there are compounds, there are two different types of structure. So I'm gonna make it, and then now we have a cut. So that looks actually okay, but then I have lost the tube, so I didn't want to lose the tube. So what I want to have is tube and the cut together. So what I'm going to do is like I'm gonna select both of them and then go to part Boolean fragments. So I want to have different Booleans, and these are like fragments of a solid. So I'm going to create a Boolean fragment. So now in this Boolean fragment I have cut and tube. So I can also try to use again space and get rid of it. There's cut and there's tube. Okay. So this is now the Boolean fragment, which looks pretty good. So I can choose different materials, but if I do that, there is kind of a problem. So let me first of all save this, by the way, in order not to get rid of it. So if I go to the FEM and then use this Boolean fragments, and let me try if it works or not, go to the mesh and see from the G mesh, I can create a G mesh and say, okay, linear elements I want to choose, and let me simply say apply. Let's see what's gonna happen. So as you see, it's not possible. So it's a bit difficult to see why it is not possible, but generally speaking, the problem is that we have here a compound, we don't have a compound solid. So let me show it what it means. First of all, I don't need this one, so I'm gonna delete it. And now let me go to the part again, and in the part I can have a look in this Boolean fragment. So there's like a view and data. So there is a Boolean fragment menu, and there is like the mode is standard. So my idea is not to use the standard. Instead of that, I want to use a comp solid. What is the difference? The comp solid means I want to have a composite, like different solids, but as a compound together, building a comp solid. So that's the idea. If I choose this one, it is still a little bit weird, but it is not ready yet. I have to choose the first of all the Boolean fragment comp solid, but then I also need to say compound filter. So now it is a compound filtered, so I don't have any compounds anymore. I have two solids. So it's a technical description of saying this part and this part, although they are different parts, but they are attached to each other. Why they are attached to each other? Because if they are attached, then on this line or on this surface, cylinder surface, I will have the same mesh, and that's exactly what I want to have. So this is now, if I go to FEM, and let's hope that this will be meshable. Now let's see if this is possible. So still I could not mesh it. So let me try to make an analysis here and then try to mesh it, because interestingly I don't have any forces on it. So let me see if the mesh is working right now. Okay, now the mesh is on the bottom of it. But okay, now you can see that the mesh is working, but the mesh is not pretty nice. It's a really coarse mesh. So what I want to do is I want to use a bit smaller elements, and then hopefully it will be a bit better. So now you see it is getting better, but still it doesn't look pretty good. So I want to use even smaller ones in order to see if everything is working as expected. And now you can actually see that we have really having the node on each at the same position for this material and or for this solid and the other solid. So that's what I want to have. I can say okay, I can even try to do some more sophisticated mesh stuff. So for example, now I have different regions, so I can say I want to have a region which is even finer. So let me go to the mesh and have a look. 1 millimeter I used. All right, so I'm gonna use here mesh region, and I want to have a finer element around the surface. So let me put 0.5 for example, and I want to have selected this surface. So it's a little bit difficult to select the surface because here it is face, edge or vertex. If I say add and I select this one, then it will select an edge from the name. I know that this is the edge, but actually I want to have the surface. So this is why I use the right mouse click and say remove selected geometry, and then I go, this task is still open, I go to the model, and in the model now I can use again space, get rid of it, and then I can use again space and show only some part of it. If I go back to task and say add, then I can select this face because now it is visible. Now let me say okay. So I want still to see all of them, or let's get rid of it, and then now to the mesh and say apply. And now it is actually trying to use a finer mesh around this solid and around this surface, and then it gradually getting larger. So around here, when I expect to see a lot of optimization, I can use a finer mesh. I can go, of course, more and more finer one, but in order to be able to do the calculation quickly, I'm just leaving it as it is. So now we have the mesh in the analysis. Now in the analysis, I want to use different materials. So one material is the one that I'm going to use in order to make the optimization. Now I don't see anything anymore because of that. I just made it out of with space. I was trying to hide it. Now here I have different materials. Of course I can choose from the list, or I can immediately put it here, or I can use the material editor. Let me think like something like a, I don't know, maybe a concrete we can choose here. Here is a concrete. The difference is only this density, Young's modulus, and Poisson ratio. So you can of course write your own numbers here directly, but let me use a concrete, which is the bigger block here. And now I want to select the bigger block, so that's a solid. I'm gonna say add this solid. You see here's a solid one, and the material is given. Say okay. So now we have one material, which is the material solid. I can leave the name as it is, doesn't matter. So now I'm gonna add another material, which can be again the same material, but from the point of optimization it doesn't matter because this one will not be changed. So I'm just going to give the same material, but I can also say no, maybe this is another material, like I don't know, maybe it's glass, right? So let's make it fancy and say yeah, this one is glass, and we are not touching it, we are not going to modify the shape. So that means now I'm choosing this material and giving them another material parameter. So the only difference is the Young's modulus and the Poisson ratio, and the mass density, which we don't use because we do static analysis. So in order to have a little bit better access, I can change the name. So it's optional, of course, but I can say non-modify, right? So it's a non-modifiable domain in my eyes. So this is why I'm saying just giving a name non-modify. So now I need to have some sort of, you know. So then of course I should not forget to reapply the mesh in order to be able to put the boundary conditions again to the mesh. So if I do this, then the rest is the same. So I use the solver, and because of in the solver I can use the task and then choose the directory that I want to have and write the input file, and then do not start the calculation. Instead of that, I go to the macros, and in the macro I can choose then the Beso topology optimization. So I already started doing it. So the most important thing is like here that we have now the possibility to choose different domains. So that's the analysis file that I have chosen, and now for the different domains that you can see, I can choose the material solid, and I can also choose the material non-modified. This is the name that we have given to the material in order to be able to easily identify that. So this non-modify is actually giving us the reason that we can choose this and then say, okay, this is not a design domain. You see, the whole idea doing it is which one is design domain and which one is not a design domain. By choosing this non-modify as a non-design domain, in the background was what this stuff is doing. you can just subtract and add elements whatever you want, but only for the design domain. So if I just use here, this is not a design domain, this will be simply left untouched. And then I start here. I already started that in the background. It is running wild and like already iteration number 12, and this is all applied only for this design domain but not for the non-design domain. So I can have a look in the paraview here. So here's the paraview. I can try to open it here. That was the topology optimization 6, and paraview is actually clever to understand that all these VTK files are belonging together. So I open that one, and you see the first 14 iterations are shown here. So I can start, of course, making like an animation that you see that the optimization algorithm is deleting objects but not deleting something from here. So maybe I can use the threshold again in order to show it what is left. So this part is left. It's a little bit difficult to see, but it's this part is untouched. So with further iterations, this will not be deleted no matter what it is. Of course, also this part is nearly all the part there because we are applying some forces, but there are no real constraints to hold them. So you can still apply the forces and also get rid of the parts of the domain. So you may say, no, whenever I want to apply a force in a particular part, I want to have this already in the design, not in the design domain. Then you can also have another additional layer here, and in this layer then define another non-modified part, and then add these parts more and more into the graphic user interface Beso algorithm. So you can have non-modifiable objects if you just exclude them from the design domain. In this way you can really do sophisticated optimization scenarios.